So it's very helpful to always think of complex numbers as points on a two-dimensional plane, which is known as the complex plane, or sometimes the Argand diagram. So if we got our complex number z equals x plus iy, we can just plot it on this diagram. Now obviously if we write r as the modulus of z, then we can also use trig to write z alternatively as r times cos theta plus I sine theta, since obviously x is going to equal r cos theta and y is going to equal r sine theta. Now this quantity theta is given a special name. Theta is called the argument of the complex number and is normally written like this: arg z, theta equals arg z. Now the thing about angles is that we're always allowed to add an arbitrary amount of 2 pi, and effectively the angle is the same. So we're free to add plus 2 pi radians or plus 4 pi radians, and we get the same answer for x and y. So for that reason, there's something known as the principal argument, which is written as a capital ARG. And the principal argument is we force the principal argument to lie between pi, if we're talking about radians, and minus pi. Okay. So if we definitely want an angle between minus pi and pi, including pi, not including minus pi, since they're the same, then we call that the principal argument and write it with a capital A. This principal argument is sometimes written theta sub p, p for principal. Okay. Now, how do we actually find this argument? Well, if x is positive, then if x is positive, then there's no problem getting the principal argument as simply inverse tan of y over x, as we expect. Okay, but the problem with tan is that it repeats every pi radians. So there's no way that we can get an angle using inverse tan outside the value between plus pi by 2 and minus pi by 2. So if we have a complex number where x is less than 0, we have to do a little bit more work to actually work out what the angle theta is. So for example, if I say what's the argument of say minus 2 plus I, then the way to do that is basically the safest thing is actually just to draw a diagram. So you've got minus 2 plus I, so that number looks like this. You've got 1 here and you've got minus 2. Okay, so one way of doing it is to work out this angle here, which your knowledge of trigonometry will tell you is opposite over adjacent, so it's inverse tan of a half, and I need to subtract this angle from pi to get theta. So theta in this case is simply pi minus inverse tan of a half. Okay. So if x is less than 0, you have to do a little bit more work to actually get the answer, the correct answer for theta. So don't just use this blindly. You can only use this if x is greater than 0.